Hello student, welcome and very good morning to you. Today I will be solving easily the I IRODOV'S numerical. Now let's start. Look at this numerical number 1. A motorboat going downstream overcame a raft at a point A, tau equal to 60 minutes later, that is tau equal to 1 hour later. It turned back, and after some time passed, the raft is at a distance 6 kilometers from the point A. Okay. Now this is the point A at which the motorboat overcome the raft. Okay. After 1 hour, the motorboat moving along this direction. So distance travel by the motorboat in 1 hour. This equals to, suppose V be the velocity of the motorboat and u be the velocity of the stream. So distance travel by the motorboat, this is the v plus u into time 1 hour. Look at this, 60 minutes means 1 hour. Okay. Now after this, the motorboat turn back. After some times, that is after the time t, the motorboat meets the raft. This is the position of the raft. So distance traveled by the raft is this equal to, look at this distance, look at this distance, this is the 6 kilometer, and time taken to reach 6 kilometer, this is the t hour plus 1 hour. Okay, no problem. Look at this, suppose this point is the B. So look at this, AB distance is equal to AR distance plus this is the BR distance. Now the distance traveled by AB by the motorboat, this is the V plus U into 1, no problem. Distance traveled by the, look at this, raft, this is the air. If the velocity of the stream U, so this distance, this is the U into T plus 1, because time of travel of the raft, this is the 1 hour and this is the T hour, no problem. And distance traveled by motorboat, this is the opposite to the direction of stream, this is the V minus U into 1 into T. Okay. So look at this, here V plus U equal to ut plus u plus this is the Vt minus ut. Okay, no problem. Look at this and this cancel out. Okay, look at this, here u and u cancel out. So look at this, here Vt equal to V, therefore T equal to 1. No problem. Therefore, time of travel of the raft, this is the 1 plus 1. So time of travel of raft, this is the t plus 1, that is 1 plus 1 hour. Distance travel L equal to 6 kilometer. So velocity of the stream, this is the 6 by 1 plus 1, that is the 6 by 2, that is the 3 kilometer per hour. Okay, understood? Now question number 2. A point traverses half the distance with velocity v naught. Okay, so total path s, half of the distance travel with velocity v naught. No problem. Okay, the remaining part of the distance was covered with velocity v for half time. Look at this. Suppose rest of the distance covered with the time, suppose this is the t dash. So velocity v1 for the time t dash by 2. Okay, and rest device, so rest v2 velocity for that time again t dash by 2. So to solve this numerical, we have to know the average velocity for equal distance. Average velocity for equal distance, this is the 2 v1 v2 divided by v1 plus v2, and average velocity in equal time, look at this is the V1 plus V2 by 2. Okay, so look at this V1 velocity and V2 velocity for equal time interval. So look at this here, average velocity for the second half, second s by 2 distance, this is the V1 plus V2 by 2. So look at this, in first half velocity is V0, second half velocity V1 plus V2 by 2. So average velocity in total journey, this is the 2 V1 V2 by V1 plus V2. So this is a 2 V0 into this is the V1 plus V2 by 2 divided by, look at this is the V0 plus V1 plus V2 divided by 2. Okay, so look at this here, average velocity, this equals to this and this cancel out. Therefore, look at this V0 into V1 plus V2, this divided by 2 V0 plus V1 plus V2, and this is the 2. Okay, this is the answer. Now question number 3. A car starts moving rectilinearly, first with acceleration omega equals to, this is the 5 meter per second square. Initial velocity equal to 0. Then uniformly and finally decelerating at the same rate omega comes to stop. The total time of motion equal to, this is the 25 second. Average velocity during that time is equal to 72 km per hour. How long does the car move uniformly? Okay. Now look at this. This numerical can be represented by the Vt curve. Look at this. This is the time t, and along this direction, this is the velocity v. Okay. So look at this. First of all, this is the uniform acceleration, then constant velocity, then look at this is the uniform retardation. Okay, no problem. Here, look at this. Here, acceleration is equal to retardation. So, time of acceleration is equal to time of retardation. Okay, look at this. If time of uniform motion is t, then time of retardation plus time of acceleration is equal to, look at this is the 25 minus t. So time of acceleration, this is the 25 minus t by 2, and time of retardation also 25 minus t by 2. Okay, now total distance covered, look at this is the average speed into time. Now average speed, this is the 72 kilometer per hour into 5 by 18. So this is converted to meter per second. Now this is the average speed and this is the time 25. So look at this is the 20 into 25. So look at this is the 500. Okay, no problem. Now the distance covered by particle is the area of Vt curve. Now this area is the area of the triangle. This is the area of the rectangle, and this is again triangle. So total journey is the area of the trapezium. Therefore, look at this 500 is equal to area of trapezium. Look at this sum of parallel side. This is the 25. This plus this is the 25 into, look at this is the t. So this is the 25 by t divided by t into, look at this height, look at this velocity after the time 25 minus t by 2 with acceleration 5, this is the 5 into 25 minus t divided by 2. So look at this is the 5 into 25 minus t by 2. Okay, no problem. Now look at this here, this 5 and this is the 500. So this is the 100. Now 2 to 4. So look at this 400 is equal to 25 plus t into, look at this is the 25 minus t. Therefore, look at this is the 625 square minus t square, no problem. So look at this, this is the 625 minus t square, this equal to 400. Therefore, t square equal to, this is the 625 minus 400, therefore this is the 225, therefore t equal to 15. Okay, therefore answer is 15 second is the time to move uniformly. Okay. Now look at this question number 4. A point moves rectilinearly in one direction, figure 1.1. Shows the distance s traveled by a point as a function of time t. Okay. Find average velocity of the point during the time of motion, maximum velocity, and see the time t at which the instantaneous velocity is equal to the mean velocity average over the first time t second. Now look at this. This is the ST graph. T is represented by second and S is represented by in meter unit. Okay. So we have to calculate the average velocity. Now average velocity for the time interval 20 second. Look at this. T is equal to 20. So in 20 second distance travel, this is the 2 meter. Okay. So average velocity V equal to distance by time. So distance is the 2 meter, time is 2 second, so time is 20 second. So look at this, 0.1 meter per second is the average velocity. Okay. Now we have to calculate the maximum velocity. Look at this, the graph is most steeper from this to this. So here time is only 2 seconds. Look at this, this is the 2 second. And here distance travel, look at this, 1, 2, 3, 4, 5. 5 means this is the 1 meter. So look at this, the maximum velocity V max, this is the 1, 2, 3, 4, 5. Look at this here, 1, 2, 3, 4, 5. 5 division is equal to 1 meter. Here distance travel 1, 2, 3, 4, 5. So look at this is the 1 meter divided by time interval 2 seconds. Okay. So maximum velocity, this is the 0.5 meter per second. Now we have to calculate the instantaneous velocity at a certain time interval is equal to average velocity. Look at this graph, this is the tangent touches this point. Okay, look at this is the tangent. So look at this, at this point, the instantaneous velocity is equal to average velocity. So time corresponding to this point, look at this is the 10, this is the 12, this is the 14, this is the 16. So at t equal to 16 second, instantaneous velocity is equal to average velocity. Okay. Many thanks for watching this video. This video will be extremely helpful for your preparation in advanced. Okay. Thank you.